demo shows a new feature in config sync. Before this feature, config sync only supports syncing from Git repositories. The main config sync reconciler has a Git sync container, which periodically pulls resources from the Git repository. Recently, config sync added a new OCI sync container, which can pull configurations in OCI images. Currently, config sync only supports OCI images stored in Google Artifact Registry or Container Registry. OCI is short for Open Container Initiative, which is basically the open industry standards around container formats and runtimes. Let's look at a quick demo. I've already set up a repository in the Artifact Registry and pushed an OCI image to that repository. I also installed the latest version of config sync on one of my GKE clusters, which is a release candidate of 1.12.0 release. I also configured config sync to sync from the OCI image I pushed earlier. Let's look at the root sync configuration. Okay, so for backward compatibility, the root sync API added a new source type field. If it is not specified, it syncs from the Git by default. In this case, I specify the source type to be OCI. I also need to provide the OCI image URL like this. Config sync supports pulling by either an image tag or digest. If no tag or digest is provided, it pulls from the latest tag by default. Similarly as the Git sync container, the OCI sync container also pulls the OCI image periodically. It fetches the image digest. If the digest remains the same, then no further operations are needed. If the digest is changed, it pulls the latest image and triggers a new reconciliation. I can also optionally specify a sync directory. In this example, no directory is provided, so it syncs all the configurations from the root directory. For authentication, config sync supports none, which means no credentials are required to pull public images. Another supported auth is GCE node, which indicates using the default Google Compute Engine service account when the workload identity is not enabled. The last supported auth type is called GCP service account, which basically uses the workload identity. A GCP service account email address has to be provided with the authentication type. Next, let's take a look at the configuration declared in this image. So I'm going to use the Korean CLI to view the image content. First, I need to log into my repository. Then I'm going to use the Korean export and the tar command to view the content in this image. So basically, the export command exports the content of my remote image as a tarball, and then the tar command lists the content of the tarball. Actually, the image was built from the Helm components directory. So let's take a look at the directory structure. It has a root customization YAML file, which basically includes two Helm charts. One is declared locally, and the other refers to a remote Helm chart. So the OCI sync container pulls the image content. Then the hydration controller will get kicked in to render the configurations. At last, the reconciler passes the rendered configurations, validates them, and then applies them on the cluster. So next I'm going to run the normal status command to check the cluster status. So now you can see all resources have been applied and reconciled. So next, I'm going to quickly demonstrate the periodic update functionality. I will upload new content to the same image URL. So here is a local directory named Customize Component. Again, it also includes a root customization YAML file, which includes 4 tenants resources. Each tenant has a sub-customization YAML file, which points to a base layer and defines the patches to be applied. The base layer also has a customization.yaml file, which specifies the resources, including a namespace, a role binding, a role, and a network policy. Then again, I'm going to use the Korean CLI to push the image. So the image has been pushed to the same URL location. Next, we can check the image again to see if the content is updated or not. So clearly you can see now the image has all the 4 different tenants directory. So after a while, if I check the cluster status again, I should be able to see the cluster is synced to a new digest and the managed resources are updated. So now let's take a look at the normal status. So as you can see, this is the previous status, which basically synced to different Helm charts, and this is the latest status, which synced from the 4 different tenants. Yeah, that's the end of this demo.